So, in our previous lesson, we saw how scientists study fossils buried deep in the Earth's sediment layers. Today, we will be looking at the phyletic lineage of organisms. That word is a mouthful. Phyletic. I know, you're curious. But don't worry, we will get to that in a bit. But before we dive into the details, can you tell me the number of species that have been discovered so far? Any guesses? 6,000? 50,000? Not even close. The actual number is 2,500,000. Wow! This figure not only reflects the number of species, but also presents a breathtaking variety of organisms with their unique features. Want to know what their distribution looks like on our beautiful planet Earth? Here it is. The insects take up the most population, amounting to 53.1% of the total species. Then, we have animals that are 19.9%, excluding insects. After that, we have vascular plants that amount to 17.6% of the total. And finally, 9.4% represents fungi, algae, protozoa, and various prokaryotes. Wow, that's undoubtedly a biodiverse collection. But wait, this list is not completed yet. In fact, it's far away from completion. Scientists believe that a total of around 5 to 30 million species are present on Earth. And as we know, only 2.5 million species are identified, leaving behind a huge number yet to be discovered. So, how do we discover these unidentified species? How can we even fill this huge gap? Don't you worry. Our skilled biologists have found a way to identify them. And that's by tracing their phyletic lineages. Yes, it's the same word I mentioned earlier. Any idea what it means? A phyletic lineage is an unbroken series of species, arranged in an ancestral to a descendant sequence, showing that each species has evolved from the one that came before it. In simpler words, phyletic lineage allows us to see how newer members of the same species are connected to their ancestors that came way before them. Now, how does that help? Well, firstly, it can trace back all organisms to a common origin of life, the first life from which everything else evolved. This means these phyletic lineages can take us in the remotest past to the very beginning of life, which kept evolving from that time until the very end, and produced many new and diverse species, leading to an increased biodiversity that we see on our planet Earth. Wow! That's super amazing! So, what are we waiting for? Why don't we simply create these phyletic lineages and pull out all the information of hidden species? You see, there is one downside here. We don't have a full record of all the life forms on this planet yet, because not all the fossils have been discovered and many soft-bodied organisms of the past have not left any fossils at all. If we had known them, we would have traced the older lineages, leading us to the secret of the origin of life.